Dear friends, welcome to my workshop. My name is Harald. This is the second part of a short series of videos on the conversion of my Weiler lathe from DIN 800 threaded to DIN 55027 short taper spindle nose. In the first part I started the work on the actual spindle nose and basically manufactured a DIN 800 threaded chuck flange. Now I will manufacture the bajonet type disc which will hold the chuck on the spindle head by means of lock studs with flanged nuts. I will use 1.7225 chromium molybdenum steel, which is already heat treated and tempered. The work starts with the usual facing and turning operations. A shallow groove is cut to facilitate the following knurling operation. I use a primitive makeshift knurling wheel holder. As my simple holder can just hold a single wheel, I have to swap back and forth between left and right hand wheels. A quick check with the new spindle nose looks good. And parting off. Yes. The backside is cleaned up. The exact thickness isn't critical, however both sides should be as parallel as possible to avoid out of balance issues. Next, I will mill 2 sets of 3 arc-shaped slots. The lock studs will be inserted through the larger 21mm holes. Stop bolts will later be inserted through the 3 other slots. The bolts will hold the bajonet disc on the spindle head so that it can be rotated through a defined angle. I can't simply use the hole pattern feature of the DRO as I have to mill arc-shaped slots. And I have to abuse my dividing head as a rotary table. Let's start with a few simple calculations. My dividing head has a 40:1 ratio. That is, 40 turns of the handle correspond to one full 360 degrees turn of the head. Thus, one turn of the handle is equivalent to 9 degrees. As all required angles are whole numbered, a dividing plate with 9 holes would be sufficient to set the dividing head to any integral angle. I don't have a 9-hole plate and I don't know if such a thing exists. However, this can be done with a 27-hole plate where turning the handle by 3 hole steps gives me a 1-degree step. Thus, the following adjustments set a 25-degree angle. 2 full turns, which are equivalent to 2 times 9 degrees equals 18 degrees, plus 21 whole steps equivalent to 21 divided by 3 equals 7 degrees. And to set a 60-degree step, 6 full turns equivalent to 6 times 9 degrees equals 54 degrees, plus 18 whole steps equivalent to 18 divided by 3 equals 6 degrees. The disc is centered in the 4-jaw chuck. and the spindle is centered in relation to the dividing head. The spindle is moved in X by 42.5 mm, which is the radius of the slot circle. The positions of the holes at the ends of the slots are marked with the spotting drill in 2 passes. In the first pass, a center is drilled every 60 degrees. The holes are pre-drilled. For the second round, the disc is first rotated by 25 degrees, followed by pre-drilling in 60-degree steps as before. All holes are opened up to 10 mm. The 21 mm through holes for the lock studs are further opened to 20 mm. This pushes my little teal milling machine to its limits height-wise. As I don't have a 21mm drill and can't use a reamer due to the lack of clearance underneath the disc, I use the Wohlhaupter facing and boring head to bring the holes to the desired diameter. In the final step, I mill the slots between the holes with a 10mm end mill. The slots are widened to 11.5mm by sidestepping the spindle by 0.75mm in each direction. This concludes the work on the bajonet disc, apart from the usual deburring and cleanup. I have to admit, this was my second try, as I messed up the first bajonet disc, which turned out beautifully, but with an incorrect number of slots, as I misread the documentation. Fortunately, my observant friends from the German Zerspannungsbude spotted the mistake. At least this thing will make itself useful in the kitchen. This ends part 2 of the series, which will continue with the work on the actual spindle head in part 3. As always, thanks for watching and see you next time.